Hi, welcome to Dissolved Chemistry. Let us continue our discussion on this haloalkanes. In the previous video, we have discussed the computation between elimination and substitution reaction in haloalkanes. All right. In the present video, we will discuss regarding elimination reactions, that is dehydrohalogenation of haloalkanes. And in that, a very important aspect that I am going to discuss in this present video is the Zaitsev'S rule. So, what that Zaitsev'S rule, where it comes, and how it is going to work. And we will also discuss where the Zaitsev'S rule is not obeyed during the elimination reaction, that we call it as anti-Zaitsev'S rule, and sometimes it is also referred as what Hoffman rule. So all that we will discuss. Okay, so let us start with this. Fine. So first thing is how this elimination reaction occurs in haloalkanes. What are the conditions that we will see? See here the elimination to occur. Okay, so the first condition is that with respect to this halo group, the beta carbon atom, this we call it as alpha, and the beta carbon atom must possess the hydrogen atoms. Okay, so if it is so, then only it can undergo dehydrohalogenation or elimination reaction. Okay, and another important thing is that we need a strong basic medium to bring this particular reaction, that is elimination reaction. Otherwise, as already we have discussed in the previous video, that there is a competition between substitution and elimination. So therefore, if you maintain the stronger basic conditions, then what happens? It will be elimination reaction and you will get eliminated product, that is alkene we are going to get. If not, so then you will be ending with the product that is substituted product. Fine. So therefore, we are using, say for example, you can take alcoholic KOH. Okay, generally we will talk about that. Alcohol, probably we will use ethanol or methanol, propanol, whatever you can use. Ethanol, preferably we will use. All right. So now in alcoholic KOH, what happens? If the base is very strong, instead of substituting with this bromide, the nucleophile, what it does, it is going to abstract the proton because it is going to act as strong Lewis base, and hence what happens? First proton is eliminated, followed by what? Bromine group also eliminates, and you will be getting the product as CH3CH double bond CS2. All right. When there is only one beta position with respect to halo group, then there is no what we call selectivity of the product. We will be ending with what? One propene, one propene as the product. All right. Now, if your bromo group is, say for example, CH3CHCS3, here if it is there, so then also we got with on the two, there are two beta carbon atoms are there, and both are containing same number of hydrogen atoms, so therefore it is symmetrical. Okay, either it abstract from this carbon or this carbon, it doesn't make any difference. You will be ending with once again what? One propene as the product. Now the question is, now say for example, so if it is 2 bromo, butane is the substrate, for example, if you consider. So then what happens with respect to this? We are having two different types of beta hydrogen atoms. Okay. So then suppose if this proton is being abstracted. Okay. So then what we will be getting in the first case? Okay. So we will be getting the product as CH3CH2 CH double bond CS2. Like this we are going to get as one butane as the product. Okay. And similarly, if the proton is abstracted from this carbon atom, so then we will be ending with what? CH3CH double bond CH CS2 as the major as a product. Okay. So now we expect, or both must have the equal probability to undergo elimination to give one butane and two butane as the product. But this is not the case. Okay. In presence of strong base, what happens? The major product will be your 2-butene. Okay, it will be the major product. Okay, and on what basis we say? So it is based on the Zaitsev'S rule. Okay, we call this as a Zaitsev'S rule, it is called. Okay, so what this Zaitsev'S rule is going to say is that if there are two different types of beta hydrogen, if they are present, then preferably the hydrogen is being abstracted by the base, so which is more substituted with the carbon substrates. Okay, so or we can call it as which contains very few number of hydrogen atoms. From that, the proton is being eliminated. What is the reason behind that? The reason is the resulting alkene is said to be more stable because it contains on both the sides alkyl groups are there. So because of that reason, what happens? It will be more stable, it is considered. Okay. So if the proton is abstracted from the carbon, beta carbon atom, which is having least number of hydrogen atom, meaning is what? It is substituted with other carbon atoms instead of hydrogen. So therefore, the resulting alkene will be said to be more stable. Say for example, we will take that one. So now suppose you take, what is this? This is ethene. Okay. So we will write like this, CH. Okay. So now when I compare this with CH3, like this, if it is there. Okay. So the doubly bonded carbon atom, if it is substituted with, okay, or all the hydrogen atoms are replaced with carbon groups, okay, like methyl or any other alkyl substitution. So then the alkene, resulting alkene is said to be more stable. So because of that reason, what happens? We are going to get a 2-butene as the major product in this case. Okay, we will see other examples also. Okay, and that we call it as what? Zaitsev's rule. Once I will repeat what do you mean by this Zaitsev's rule? Okay, when the haloalkene is unsymmetric, okay, or if it contains two different groups of beta hydrogen atoms, then during dehydrohalogenation, the proton is abstracted from that carbon atom which contains few number of hydrogen atom compared to more number of hydrogen atoms, okay, as a beta hydrogen, leading to the formation of the major product as more substituted alkene. Okay, so that is what is Zaitsev's rule. We will take little more complicated example and let us try to understand. Okay, so now let us look into this substrate. We are having three different beta hydrogen atoms are there. Beta hydrogen atoms. So this is one which is primary carbon atom. This is secondary. And these two are identical. Either you abstract proton from any of the carbon atom, it doesn't make any difference, or it will be means the same thing. Okay. So now according to Zaitsev's rule, so instead of abstracting proton from the primary carbon atom, so the proton is abstracted from the secondary carbon atom by the Lewis base or the strong nucleophile, what we call, or strong base we can say. Okay, and leading to the product as major product, and this will be your minor product. Okay, minor product. What is the reason behind this? Now, this doubly bonded carbon atom, here you can see it is substituted with two carbon atoms, and here it is substituted with another carbon atom. Okay, whereas here you can see that only one carbon is substituted with other carbon skeleton, whereas here both are hydrogen atoms. So therefore it is least stable when compared to this one. So therefore this is more preferably formed according to Zaitsev's rule in presence of strong base. Okay, so next is, all right, in all the cases the Zaitsev's rule is not being followed. Okay, so we'll see in what conditions that we are going to get the product which is anti-Zaitsev, we can say. Okay, or it is also referred as what? Hoffman product. The first condition where we won't get this Zaitsev product or Zaitsev rule is not followed. So that is when we use bulky base. Okay. So if the base is bulkier, then what happens? Zaitsev's rule is not followed. Okay. The same example what we have discussed in the previous one, that we will see. Bulky base means how? Say for example, if you take sodium ethoxide. All right. What is this? So it's not that bulky, we can say. So now instead of this, if you take like this, tertiary butyl oxide, okay, CH3, O minus, Na plus or K plus you can take. And this is sodium tertiary butyl oxide. And this is said to be what? Bulkier base. Okay. So now when you use these two, okay, so your product will be different. For this, your major product will be Zaitsev's product, and in presence of this bulky base, your product will be called as what? Hoffman product or anti-Zaitsev's product we call. Okay, so both we will see and we'll try to illustrate that. Right? Let us take the same substrate what we have discussed. Okay. All right, both are identical, so therefore only one I will consider. All right. So now suppose if you are using sodium methoxide minus Na plus, and in another case what we are using CH3 taken thrice CO minus Na plus, or you can call it as what? Tertiary O minus K plus or Na plus we can take, right? Na plus, tertiary butyl oxide. Okay. So now when you use this one, then what happens? Your major product will be Zaitsev's product. That is, you will get this as the product. Whereas here we are going to get major product. All right. Now, how we can explain this one? Okay. In presence of this bulkier base, what happens is that this removal of the proton from this carbon, okay, it is theoretically hindered to reach this base to get this proton from here. So therefore, what it does, so it is readily, it can take up the proton from this free primary carbon atom or methyl group rather than taking hydrogen from the what? Secondary carbon atom where it cannot reach properly. Hence what happens, it is going to prefer this one, and this reaction we call it, or where we are going to get major product, anti-Zaitsev's product, also it is referred as what? Hoffman product, and the rule we say that as Hoffman rule when what? When you are using stronger base or bulkier base, we can say, not stronger base, bulkier base. Okay, so therefore which we call it as what? Hoffman product, and or it is also referred as what? Anti-Zaitsev's product, and here it is referred as what? Zaitsev's product. Okay, so what is making the difference? The bulkiness of the what? Base. Okay, bulkier than anti-Zaitsev's product. If it is smaller, so then we will be getting Zaitsev's product. And the condition, other condition is we must have stronger base to have the elimination reaction. That condition we won't compromise here. Okay, so all right. There's in other case where this Zaitsev's rule is not followed is that when the group is poor living group. Okay, so if the living group is very poor, so bromo it's a good living group, chloro it's a good living group, iodo it's a good living group, whereas your fluoro is not a good living group. If the fluoro is there, okay, so then what happens? You will be getting anti-Zaitsev's product as the major product. So what is the reason for that? So that we will see, and we will move on to the next. When the poor living group is present, all right. So for example, we will take the same example. Instead of bromo, we will take fluoro, right? All right. Okay. Now what happens? You are using common base, same base you can use. Sodium ethoxide you can use. All right, in both the cases. But still what we are going to get is O minus Na plus All right, it's a fluoro. Okay, so now what happens, as it is a spore living group, okay, if the proton is abstracted from this carbon atom, then what you will be getting the intermediate? FCS2 minus. Okay, now this will be the intermediate. And here, if the proton is abstracted from this beta carbon or secondary carbon atom, this is primary. Okay, now what is going to happen? All right. So now look into this. So if the leaving group is poor, then what happens after abstraction of the proton? It delays the leaving group to leave from the substrate. Okay. So therefore, the formed carbon ion should be more stable. Then only what happens? That will be obtained as a major product. Okay. So therefore, if you want a Zaitsev's product, but still leaving group is not ready to leave readily, so then what happens? The formed carbon ion is secondary, whereas here it is formed carbon ion is primary. So therefore, when you see the order of their stability, primary carbon ion is said to be more stable. So therefore, it is more preferred when the leaving group is poor. Okay, why? Because it can stabilize the formed carbon ion. Here it is difficult to stabilize the carbon ion formed, as the leaving group is not readily going to leave, or it is reluctant to leave the substrate. So therefore, your product will be what? Anti-Zaitsev's product. Okay. So therefore, this is the product what we are going to end as the major product. Okay. So this is the second case. And the third case is, so if the abstraction of the proton leads to the formation of conjugation with the other pi system in the substrate, so then that is more preferred rather than what? Abstraction of the proton from the fewer number of the hydrogen atoms on the beta position according to Zaitsev's rule. So that one we will see. Third limitation is when the conjugation results by elimination. Okay, we will see that one. Okay, we will take the substrate. Okay, let us illustrate what this substrate means. Okay, you find here one hydrogen atom, and you will be having two hydrogen atoms here, and this carbon is tertiary, and this is secondary. According to Zaitsev's rule, what we expect, the proton should be abstracted from the what? Tertiary carbon atom. Okay, and we expect. Now let us look into both the formed product. All right. So if the proton is abstracted from this carbon atom, the formed double bond is in conjugation with the pi system already, which is existing in the molecule. Whereas here what happens, it is not in conjugation with this. Compared to the presence of pi bond on the more substituted carbon atom, if it is in conjugation, it is said to be more stable. So therefore, this will be the more preferred product, or it will be the major product, due to what? Even though the proton is abstracted from the secondary carbon atom, so leading to the generation of pi bond, which is in conjugation with the already existing pi system in the molecule. So therefore, the conjugation, it is in conjugation with this. So conjugation makes more stability, or we are going to get more stability to the molecule than compared to non-conjugated one, even though it is having more carbon substrate. So therefore, this is the major product we are going to get. Okay, and which is anti-Zaitsev's product. And this has appeared in JEE Mains 2024 April, whatever the exam is being held. This one is being asked, which is the major product. Okay, so be careful that where Zaitsev's rule is applicable, where it is not applicable. Okay, so all that we have discussed, I hope you have understood. Please Don't forget to subscribe our channel and please inform to your friends also. Thank you for watching.